Ionocaloric cooling. This is an exciting topic because it could completely change the face of refrigeration and air conditioning, moving us away from harmful gases that are warming our planet and offering a safer, more efficient alternative. What's going on here, John?
Yeah, this is cool. I know we've covered refrigeration, I think, once or twice before in the past. This is a new one that we haven't covered. So scientists at Berkeley Lab, they've invented a completely new way of keeping things cool that's been inspired by how salt melts ice on winter roads. So what they've done is, instead of using harmful gases like traditional refrigerators and air conditioners, this ionocaloric cooling method, it uses salt and electricity to create cooling effects. Now, how it works is pretty simple. Just like adding salt to ice makes it melt without adding heat, this technology uses salt particles called ions flowing through a special liquid to make cooling happen. So when electricity flows through the system, it moves these salt particles around and it causes the liquid to freeze or melt in ways that absorb heat from the surroundings, essentially cooling things down. So why does this matter, right? It matters because, for those of you that don't know, current refrigeration systems, they use gases that are thousands of times worse for global warming than carbon dioxide. So this new method could replace harmful chemicals with completely safe, recyclable materials while potentially being more efficient and cheaper. So we're not there yet, though, for this to be useful. In their first test, they did achieve a 25°C or 45°F temperature drop using less than 1 volt electricity, which is better performance than other experimental cooling options. And those other ones are, I think we talked about elastocaloric, we covered, but then there's air-based, but then obviously there's vapor compression. So what are your thoughts on this, Craig? Do you think this is a potential here?
Well, this is interesting, and I'm going to dumb it down for people here. So it's a new way to cool things down, just using salt and a tiny bit of electricity instead of using compressed gas, right? It moves ions from salt in a liquid, and when the ions move, it causes the material to melt and absorb the heat, making things cold.
Yeah.
So when the process occurs, it solidifies and releases heat. Think of it as a rechargeable cooling cycle based on salt melting, I guess. I like it. I just don't know if it's really going to move the needle in the cooling industry. I mean, it sounds all nice, but how much cooling power are we going to be able to actually produce? What labs got us so far at, John?
What do you mean?
Well, the cooling systems achieve temperature changes from 28 degrees using less than 1 volt of electricity. So I'm saying, like, how much are we actually going to be able to cool this technology? Is it going to be like a whole room? Is it really going to get us much cooler? Is it just going to get us a couple of degrees?
I think we're going to be able to surpass. So they're targeting systems capable of achieving temperature lifts exceeding 50°C, which is what's required for practical refrigeration applications. The other one that we had covered, which is elastocaloric, that's achieved a 75-degree temperature lift. That's a record, but they're in the prototype stage. So ionocaloric is in early prototype. Elastocaloric is in a prototype stage. And then obviously we've got vapor compression, which has a greater than 50°C temperature lift. The thing with the ionocaloric is it's a 30% efficiency versus other ones, which elastocaloric is variable, air-based, it's a 50% efficiency. So we're getting there, but we're still in the early prototype stage, whereas the other ones are, like, the air-based is at development stage, elastocaloric is at the prototype stage. So we're still early stages.
Yeah, and over 50% of homes' energy goes to heating and cooling. So potential HVAC systems, commercial refrigeration systems, battery thermal management in electric vehicles and so on, and industrial process manufacturing and data center cooling. I'm just not 100% sold that this, out of all the cooling things that we've looked at and that we've seen coming out, that this is going to be the one. Is that fair to say?
It's fair to say, but here's the thing. It's a solid state technology, right? So
Yeah.
that eliminates concerns about refrigerant leak, which is the hydrofluorocarbons, HFCs, which is used right now. It reduces maintenance requirements, and it potentially offers longer operational lifespans than current conventional systems, not the other refrigerant technologies that are being developed. Now, I'm guessing that most of these companies, the appliance companies, aren't going to like that it's a longer lifespan, because then that means they can't sell you as many replacements, right? But I think this has potential. I know hearing salt and using salt in a machine, but it's not salt, it's ions, right? In a refrigerant type system might cause some instability or things like that, but I think there's a lot of potential here. What, you don't think so?
Hey, Mylan, thanks for watching and thanks for saying hello. I think there's potential. So I look at this saying, okay, so the ions move through the salt and it melts, and that releases energy.
Yeah.
Which is great. And then the same happens when it solidifies. So my problem is that you only have so much. So how much salt of this type in how big of a container will it take to cool a whole room in the summer? Because at some point it's going to be solid and it needs to melt completely, and then sometimes it's going to be melted completely and it needs to go. And when it's the other way, it's going to be releasing heat. So I look at it little like a heat pump, I guess, which says cool and heating. But the problem is you can only do it when it's all melted. You can't melt it anymore, and when it's all solid, you can't make it solid anymore. So how much do you need?
That's true. Yeah. I don't know, but I think what I was reading is they're looking. So they're still in the R&D phase, right? So I think that, like, even at the early prototype stage of how they've developed this, I think there's potential for this to, I don't know, maybe it's not in HVAC systems. Maybe it's being used in other systems that support this. Maybe it's that. I don't know. But I think this is a technology that will be commercialized at some point. In what capacity and what application? Who knows? Maybe it's in data centers.
Yeah, and I think it looks like, based on the research, they're already trying to improve the life cycle beyond the current prototypes and extending the operational commercial viability. And they want to achieve up to 100 degrees with the changes with the advanced materials. So, maybe my skepticism is unduly put towards this. It looks like it's going to be a very interesting technology. I'm just not sure if it's actually able to do what they're talking about. Is this actually going to be industrial level cooling 24 hours a day? Where does the heat go? Is it ejected outside like many of the other things? I guess that's easy enough to do.
Yeah.
So I guess it's easy enough to do. They probably already figured those things out to some degree, and maybe my concerns are unwarranted. It just feels like, at some point it won't be able to cool anymore, or it won't be able to heat anymore, depending on which way you're going.
They've got to have a solution for that. Maybe not, but so apparently, like, there's major HVAC manufacturers that are actively seeking breakthrough cooling technologies, and apparently the global HVAC market is projected to exceed, I didn't realize this is huge, $280 billion by 2023. Or sorry, 2030. 2023.
And I guess they're using liquid phase materials that are pumpable, so solving some of the solid state limits. So if you can pump the salt through, then it can exist in another state somewhere else and, form either a solid or liquid and come back through. So absolutely, they probably solved this problem. I'm just, again, how much does it take? How long does it take to switch states to come back and be reusable? So again, how much do you need? I like the idea. Yeah. It looks great. It looks like it's going to be low energy. Anytime we can come up with solutions that are better for the environment overall, or lower energy, because let's face it, AI is going to take all the energy it can get. And so every volt that we can save, it will scoop up and do. But we'll do our best to keep this low voltage stuff happening. I love where this is going.
let's geek out for a second. So
Okay.
how the system operates. So it controls the flow of electricity charged atoms or ions from salts through a working fluid. And so that's typically ethylene carbonate. So when the electric current is applied, ions migrate through the medium, fundamentally altering the material's melting point through a colligative properties, which is the same scientific principle behind road salt preventing ice formation. So the ionic concentration change, it forces a solid to liquid phase transition, and that absorbs latent heat from the surrounding environment, which creates a cooling effect. So the process is also reversible. So when the current is removed or reversed, ions are extracted, the material solidifies and releases heat, completing that thermodynamic cycle. Does that make a little bit more sense to you?
Definitely makes more sense. Again, I'm just curious as to how fast that all happens, right? And how much you would need to cool a large room versus like how big of an air conditioner, like on equivalent size, what's the equivalent of a 5,000 BTU or a 50,000 BTU size from something like this? That's, I guess, what I'm trying to get at. That can run 24 hours a day.
Yeah.
But I'm obviously they're moving on it. People are really looking into it. And I love the concept of it and that they're moving this forward. Like, this is ionocaloric cooling today is a technology. It's at the early stages, but its a promise is massive. And we'll keep a close eye on this like we do with other cooling technologies. And, maybe I'm a skeptic, but maybe this is the one who's going to run through and we'll let you know what happens as it goes along. Will this tech finally be the one that cools our homes and our planet? Let us know what you think. Leave your comments below. What do you got going on, John?
Yeah. Just gearing up. Is this coming out in December?
Yeah, December might even be January now, actually.
Okay, gearing up for the holidays or gearing down from the holidays. So planning out my next few months and, ramping up for shred season. How about you, Craig?
Well, we're wrapping up 2025 and planning 2026. So this is probably too late for the start of investor drinks and Flowgrammer events in December, but take a look for them in January. There's always stuff going on. Check out torontostarts.com for our startup and business related events and resources. And check out flowgrammer.ca for our business and AI automation information if you're looking for that. And if you're a builder in Toronto and you want to join the Flowgrammer Builders Club, head over to flowgrammers.ca. That website is live now. Go check it out. Join us and at our live events. We do online stuff. We do live office hours every week. Go over there and sign up. There's downloaded workflows and tools you can test and play with. So check all that stuff out. But John, if people are looking for non-dilutive funding, where do they go?
Yeah, come find me on LinkedIn. I've got a link. You can book some time with me or send me a message so that we can have a conversation first. But find me on LinkedIn, John Irwin, no H. But if you need help with your business overall with your startup, how do they get in touch with you, Craig?
Head over to startupcoach.ca or torontostarts.com and just book a call with me and get a discovery call, find out what's going on and get you motivated. If you're not interested in that, come out to one of our events, talk to other founders and whatnot, and just talk to people. It really is knowing that you're not alone can motivate you a lot. But other than that, give us a call or book a meeting over at torontostarts.com. And thanks everyone for listening or watching, and hope to talk to you again soon.